Hello.
Guys, let's sit down. We're starting the meetup. Okay. All right. So first of all, thank you everybody for coming here today. We really appreciate taking your time together with the people here. This is the API meetup we're having in Barcelona. This is the first edition that we are kind of revamping this meetup. Just out of curiosity, anybody that was attending the previous meetup that then it was shut down? This guy over here. So this is Andre. My name is Vincenzo, and he was one of the guys that was organizing the meetup back in the time. So we're going to go a little bit through the history and what we want to do next. So the meetup basically started by three guys in 2015, by Nicolas, which is not here, by Manfred, that maybe...
Manfred. This is the guy.
Here he is. Okay. And Andre over next to me. And their original idea was, a quarterly meetup, once every 4 months, vendor agnostic, and as a networking event. This has been going for a while, and then the team has fallen apart because Nicolas moved to San Francisco. Andre said to me, I'm going to move to Zaragoza because I left Rescale in Barcelona in the quest of the meaning of the life, wondering if he found the answer. And Manfred was the only guy here willing to keep up with the meetup. He kept the community in a steady way. And then fast forward in 2018, we are in Paris at the API days, and basically me, Andre, and Luca, we meet and we say, why are these cool things always happening in United States or all the states around? We're not Spanish, of course, but we said, why is it not happening in our country? We need to do something. And we agreed together that once we go back, we need to revive this. So we went ahead, we created a meetup. This is probably the page you signed up for. And we were aiming to a certain number of people. We received 115 kind of willing to participate intention.
We'll see how many come.
It didn't really reflect in the people, but we're going to take these as a starting point. And another important thing, thanks for the sponsor. It wouldn't be possible without them. The first one, Typeform, that provided this beautiful location over here. I think it's one of the best offices I ever visited in my life. OutZero, that has been paying for some expenses. I don't live in Barcelona, I live in Madrid, so they took care of my stuff and also sponsored some of the food. And Tick.io, that also been helping with the food and other related things. So our speakers tonight, I mean, it's their show, not our ones. Leonid from Tick.io is going to be talking about implementing and securing an API gateway written in MQTT. I'm personally interested in this because I've wrote an API gateway. Then Sean Mulligan from Balena is going to be talking about how to prototype and release server for IoT devices. And last but not least, Iago Carta will be speaking about how to throw millions of IoT devices on a map. So without any further ceremony, I invite Leonid to come here on the stage, give it a round of applause, and enjoy the meetup.
Okay, perfect. First of all, thank you all the organizers for doing such a nice meetup. And yeah, place is definitely really, really good. It's actually the best place where I did talks on Meetup. Well, anyway, so my name is Leonid. I work at Dyke. And I quite long in software engineering. I lead engineering at Tike actually. For the last 7 years, I working completely remotely. And for example, our Tike is fully distributed team. I travel the world a lot and really like it. And the topic of today's talk is quite interesting, especially in the case that it come up just 3 weeks before the talk, when organizers asked me what kind of talk I can do in terms of APIs and IoT. I had no idea, so I tried to enumerate all the possible crazy ideas and came up with the idea of writing some gateway for handling MQTT, for handling IoT devices, and especially for MQTT protocol, which is the most common protocol in this industry. And the most interesting part that nothing of it, what you described here, was not created before that. So it's completely a fresh new code, and it's definitely very buggy and etc. But anyway, it's kind of works. So first of all, I can use this. Okay, perfect.
No, and also I think there's one slide behind. Like, make sure that your screen,
Oh, right.
Yeah, you know.
I see. Makes sense. Okay.
But you can also watch it there if you like.
Okay, thank you. So since this talk is about IoT and MQTT, how many of developers here know what MQTT is? Okay, that's quite nice. That's better than I expected. So since this is quite specific product and standard, so let's simplify my job. So Tike itself is an API gateway or API management platform, how it calls. And the main idea here is that you put it on top of your services, APIs, whatever you have. It helps you to deal with all the boring stuff like analytics, monitoring, and all with minimal engineering involvement. And the general idea that when you actually start working on your service, on your API, you have a really cool idea, but then when you need to actually release it to production, you end up in a situation when, in addition to your core idea, you have to build all the stuff on top of it. Application, analytics, integration with third parties, developer management, some regulatory requirements like audit or security management, and etc. And you actually end up in a situation when you have to build everything or somehow to offload the stuff to another system. And this is where API Gateway comes in. So it allows you to manage all this boring stuff for you. And so you will focus on your core. And while doing research, what kind of stuff in this context happening in IoT industry, I find out an interesting thing that while all web developers complain that all the development became so complex and all this kind of stuff, but at the same time, they have a lot of tooling around it, like API gateways, different frameworks, debugging tools, and etc. But for IoT world, there are not that much, especially when it comes to developer experience. And you definitely can find something really costly like CA mobile gateway, which can cost you a leg or an arm, and or you can find something like lot of implementations of MQTT servers, which are really performant and all the stuff, but they are really very technical and not flexible, etc. So, and before actually we start with the gateway challenges, I wanted to all of you to understand what's the actual problem we're trying to solve here, because IoT topic is quite relatively new, and there are some unclear stuff here. So first of all, security. It's obviously that when you have a lot of devices, someone will try to hack it, use it to send spam or whatever you want to use. And it's really concerning right now because we see a lot of cases when smart refrigerators or similar gets hacked and just used for attacks or whatever it is. And in general, industry right now in a gold rush in a sense that no one knows where it goes, no one knows what to do, but everyone wants to do it. Right. And in terms of connectivity, imagine that you have right now, let's say, you released 1,000 devices, but what when you grow to the billion devices? What if you go went well? And in this case, current solution mostly offers you some single point of failure, right? So how to deal with such big amount of data and devices in general? It's also not clear. Next, obviously, longevity, compatibility. So right now, as mentioned, there are so many technologies, so many startups which trying to focus on IoT, help developers to start up, and etc., including us. But what will happen in the next years? Most of them will go on, and devices which we used devices which were built using these frameworks and tools will just stop working. So in general, problem with IoT means that if previously you buy some electronic device, you can ensure that you can turn it on, off, and in general work for the next 20 years. Now, when you buy it, it can work only until its software works. So it's actually, you're actually bound to the software. Now, actual standards. So the whole IoT topic really miss basic standardization. So yes, we do have MQTT standard, but it's very simple and not really flexible, and it's more like a guideline than the actual strict standard. You can do whatever you want with it, and as we need some force which brings standardization, and so everyone will be compatible with everyone. And right now it's a mess. So regarding what actually drives adoption of the IoT, right? So the lower prices for the machines, the more devices there will be. We constantly see increase in what individual devices can do. And in general, machines starting to influence human behavior in the sense that, for example, let's say you have auto-driving machine, which actually is also IoT device. Soon you will not be able to live without it, right? When it will be everywhere, and it's become part of our daily life. And deep learning tools mentioned here as well, because such immense amount of data which we generate even now with current amount of devices is such big, and it's not clear what to do with it. Do it just a garbage, or we can actually reuse it somehow and create something useful from it. And I guess we'll definitely have some talk here about mapping of some IoT related data, but still. And challenges actually that what to do if something bad happened. Like what if car had an issue and hit someone? What to do if you have smart kettle and it just blows up because it hits up or similar, or it receives some signal from the internet with that it needs to be turned on, and etc. So it's literally not clear how to deal with such security stuff. And what to do, for example, if I have smartwatch and I want to buy new version. Will all my old data will be transferred to new version or not? Can I just switch device to another version? It's hard to do. And in general, slow adoption of new technologies, because we seen a lot of IoT stuff which are in developing and etc., but not that much stuff which actually gets used. And it's going to be used way, way, way more in future. And one of the main drivers is obviously a business, right? So smart devices and IoT is not just one single topic like for phone or watches and etc. It's way bigger. It's used everywhere, from wastewater system, pipeline monitors, medical devices. So it's actually everywhere. It can be used for cardiology monitors, etc. It's actually everywhere. And the more problems going to be solved in terms of IoT complexity and all these issues, the more businesses will realize that they will need these solutions. So it will be exponential growth in my view. And in terms of society, we have issue with, first of all, users. It's hard for users to trust all those devices, especially when we read news when, like some Facebook device or Nest monitoring system actually has a microphone which tracks all your audio and sends to Facebook servers. So who will going to install this stuff in their own house after such leak, and etc. So how there are not enough successful stories from privacy point of view for actually to trust, to have enough trust and enough adoption. And in general, people assume that if they have device, it just works, right? But even if you're talking about some complex system, like not consumer devices, but let's say electrical pumps, monitoring, and all this kind of stuff, it's still not enough learning in terms of security best practices, like changing default passwords. So if you go right now into the internet and try to scan with TCP scanner, yeah, oops. If try to find a TCP scanner with some standard ports, you will find hundreds of devices which you actually can access and do whatever you want with them in a lot of the cases. So it's like it's really crazy. I recently did some experimentation, and there are tools which allows you to scan the whole IP4 internet if you have good connection in like 24 hours. So it's not something which require you to have supercomputer. You can do it on your own MacBook and have good connection. And obviously, as mentioned, privacy, but not only in the context that it shouldn't leak any data, but also people should choose what kind of data they're ready to share. So for example, they have a device and they can go to the smartphone options and tell that I don't want to share my talks with third party. Or maybe someone will want, I don't know. But right now, no one actually tells us what they do with this data. They track everything. They tell us that it's secure. But actually, from regulation points of view, there are no any regulations. So it's not clear what's happening with the data after, who access it. And we see a lot of cases when a lot of companies which build IoT devices actually sell this data to third parties. And actually, that's one of the main income sources. So that's something which should be dealt on the government level, on the laws level. Right. So now back to MQTT. So MQTT in general is a protocol which right now is a standard for IoT devices. And the main reason that it's very lightweight, open source, and it's actually one of the not many standards which was confirmed by IoT organization or whatever, I don't remember its actual name. And in general, it has very small code footprint, and it's specialized on the network bandwidth. So you should be able to send data as fast as possible and with minimal footprint. And it's obviously ideal for constrained environments. And it has really nice features, like, for example, when you have IoT device, it's usually do not have connection with internet all the time. It's just enabled, turn on, turn off, and etc. It can be enabled on timer or whatever it is, or you just ride in a car and your internet connection gone, etc. And MQTT in this case allows you some interesting stuff like sending. Client can subscribe to some topic, and if it's interested in it, even if he's offline, and when he goes back online, he will still receive this data. So, and also there are some interesting stuff in MQTT protocol specific. So for example, a device can notify you when it dies. What to do when connection goes away. So when you connect, you, for example, can specify so-called last will. And when, for some reason, connection just drops, server has this information, and last will can be like this. Notify some channel that device is offline. In this case, notify, for example, my smartphone application, right? So, and in general, idea is very simple. We have a publisher, we have a broker who manage messages, and we have subscribers. If you're not aware with MQTT, the closest thing to broker can be something like Apache Kafka, right? So you send some data in, you can subscribe to some topics, you can guarantee message delivery if needed, and etc. So that's what MQTT brokers do. And actually, there are quite a lot of interesting and quite powerful brokers. But what they actually miss is this flexibility and configuration part. So for example, you can configure them in some config level, in file or whatever, but you can't really change credentials easily and all this kind of stuff. But we can talk about this later. So the main role of the broker is to receive client subscriptions on some specific topic, receive messages from the client, and forward these messages to interested clients. And the purpose of the client is to publish messages and to subscribe to topics they want to receive. And one of the interesting features of MQTT protocol is the quality of service, which is kind of missing in a lot of protocols like HTTP. So you can actually specify how you want to treat your data, how important your data. Do you want to just fire and forget, or do you want to guarantee that at least one message will be delivered, or exactly once? Or for example, in case of MQTT sensor data extension, you can tell just don't care about delivery. I just send data. I don't care if it will be received or not. But obviously, if you have like billions of devices, it can be your option, right? So, and everything comes with own choice. Obviously, if you want to do exactly once delivery, it puts some performance constraints because it's quite hard for the broker to do that. And what's interesting, MQTT protocol used actually in a lot of stuff like Facebook Messenger. So it's built on top of MQTT and inherit all these benefits. So if you have bad connection, etc., it just works. You receive messages back if you went from offline to online, and everything done with MQTT. And that's also was quite interesting exploration from my point. Yeah. So existing MQTT development tooling. I researched it. So as I mentioned, it's too enterprisey, and you have to, like buy it for $1 million or similar. There are some hardware solutions which also very, very costly, and there are some custom implementations of the different brokers, and you have to write the rest of the stuff by yourself. So you can have your application script which talks to the broker, but all the related authentication and all this kind of stuff, please do it by yourself. So, and in general, if we're talking about API gateway world, Tyke right now lives in the web architecture. So it means that we work with HTTP, we work with, for example, even WebSockets. It's a bit exception, but still. But main idea is that it's a custom TCP-based protocol. It's bidirectional. It means that one request not always comes with the one response, and requests and responses can be asynchronous. And obviously lack of standards. So how are you going to implement it, this or another way? And in this case, when I did research, gRPC implementation was actually my inspiration. We recently implemented gRPC proxying in Tyke, and the main idea that gRPC itself is also a binary protocol, but it uses HTTP2 as a transport. And interesting here that all the meta information and all the non-binary stuff which you can extract actually mapped to HTTP, like HTTP method, HTTP path, custom headers, so you can actually access it. And I decided to do the same way for MQTT. So packet type, like for example, I want to publish or I want to subscribe, can be just HTTP method. Topic can be a path. Some meta information like quality of service can be a header. Body of the message, payload, just maps to body directly. And in case of error or success, we can just map it to HTTP codes. And implementation itself works really similar in the context that there is some parser of MQTT which translated to some virtual HTTP request, which obviously not HTTP compliant, but it's made just for the purpose of working inside the gateway, because because of this property, it will be able to reuse all the code and all the stuff we built for HTTP. Then we run it through the standard chain of our HTTP plugins, which we already have, and on the output we convert it back to MQTT message and send to the server. So what features supported? authentication, authorization, analytics, configuration, and protection. And we'll go through them one by one. So what is authentication, right? It's to say, am I allowed to user in or not? In this case, MQTT allows some really basic stuff. So you can specify username and password when connecting to the server. And it obviously maps easily to basic HTTP authentication. But in case of more complex stuff like JWT or OpenID, you actually can use it. You just can do some hack, for example, put username to JWT and put JWT in actual password field. And it actually works pretty fine. And it's not who I'm invented this. It's actually from a lot of articles on the internet on how people try to mitigate MQTT limitations. And authorization. So authorization is actually, is this user allowed to do specific action? In this case, is the user allowed to subscribe to some topic or receive data from some topic, right? And by design, MQTT sends some unique client ID, which, for example, let's imagine you have a factory where you need to create 10,000 devices. You can embed some unique ID to each device, obviously, but from what I understand, it's really rare that credentials for these devices actually different. It's in a lot of cases you have same user password, but just different client ID. And I made it work with Tyke actually. So basic idea here is that when you receive, when Tyke sees the client, it creates some internal key token representation for him and maps him to the policy where he have access rules based on this login password. And then when you have this client ID or another way, let's call it token, you can actually do the granular permissions for him if you want to. So you, for example, can say that for given topic, I'm allowed to publish and subscribe for this topic. Right? And because we inherit all the HTTP related stuff, standard log browser for viewing list of requests I made to the server just works. Just instead of get, post, and put methods, you see connect, subscribe, publish, and what in terms of MQTT. So you can see that if request was successful or not, how long time it took, what kind of topic it was, and you can see actually detailed analytics per request. In this case, if it's mapped to HTTP headers, I can show them here as well. I can see the client ID, and I can actually see the payload, which, for example, was sent from the sensor or whatever it is. And next is configurations and transformations. So it brings us to also interesting topics that because of nature of HTTP, there are stuff like URL rewrites, body rewrites happening in Tyke built-in right now. And because MQTT message just becomes HTTP message, you can do everything with it, right? You can forward from one topic to another topic. You can rewrite payload of the message if you want to. You can apply conditional logic on metadata. So for example, let's say for some specific client, you want to allow only one quality of service, specific quality, but for the rest, disregard this client. Or for example, with time, one of the data became more important than another one, and you decided to upgrade quality of service. You don't have to modify all the devices. You can just set it in the road configuration that now quality required to this level, and that's all. And same for your last will logic and etc. And also, you can use all the tooling built for the Tyke. So for example, we have a special model which allows you to log all your requests to Elasticsearch, to StatsD, or whatever logging tool you use. It means that you can just use this as drop-in solution, and you will have all the logs for your MQTT broker in the provider you want. Now about protection. So since we actually can map individual MQTT client with some unique identification, let's say KO token, we can apply some rate limits or quotas on it. And for example, we can say that single sensor can send more than one publish request per second, let's say so, and to avoid some DOS protection. And for example, we can apply throttling. Let's say that this sensor hits some rate limit, but we still want it to send the data. In this case, gateway can automatically do retries until the rate limit will allow actually data in. Dealing with mail for data, right? So you're putting some protection layer on top of your MQTT broker. So if someone tries to DDoS you, send you the wrong request, and etc., all those requests will be rejected before it actually hits your infrastructure. You can whitelist and blacklist topics. So you in complex IoT architectures, you have thousands of different topics. Some of them are internal ones. For example, when admin dashboard can subscribe to them and show some detailed analytics. Some of them public ones, which sensors can access. And you can granularly and most importantly, dynamically change these permissions. So you don't have to restart the server. You don't have to do anything of this. You can change it either on global API level or for individual client ID. So for example, if you have a device which you're testing internally in your company and and you want to enable some beta feature for it, you can enable specific topic for this device and you will be able to access it. And obviously stripping sensitive data, what we talked before. So let's say we found out that sensor sending some data we don't want to receive. And we can just anonymize it, for example, right? Directly on gateway level, and we can do request transforms, response transforms. Now performance. So what I'm talking here is really we didn't perform big load testing, etc. But I think this numbers is overestimated because in general, MQTT by nature is way more faster than HTTP because it doesn't have to establish all this connection, multi-flow connection all the time, etc. And it can be way more faster. So what I'm showing here is some unoptimized version, but still it's very performant. So and now let's go to step 6, as it says. Can I go just okay? Let's. So based on what I just described, I just wanted to quickly review the main challenges for IoT and how implementing solution like Gateway on top of them can solve them. So let's say we have hacking and etc. So if you put Gateway on top of it, you can limit what this device can do in general. So you can, for example, forbid cases when someone finds that there is some topic which is used by all your devices and not blacklisted and just sends some malformed data and somehow hacks your device. You can see this in analytics, track what's going here and dynamically block it, like this, for example. Yeah. For connectivity and Tyke itself supports installations in multiple data centers and etc. So if you put it on top of your broker, it means that you automatically get the same benefits. So you can have multiple data centers where Tyke is installed, and actually Tyke will be talking with your broker. Right. So you can have really big installations based on this property. Next, connectivity. And now imagine that some device was released and you found some, I guess it's a nightmare for IoT developers, like if a device was already released, but some bug was found. So how's they going to fix it? So some devices offer updating firmware, and for example, my colleague from Barcelona going to show how to set up infrastructure and to update these devices dynamically, firmware, etc. But in most of the cases, it's just not happening, and you have to put patch on the patch on the patch, and somehow mask this issue from the user. And in case of the gateway, it can be done in lots of the cases without developer involvement. And this is very important property because you can lose a developer, you can, whatever can happen here. And in terms of longevity, so even if some servers will, will die or whatever it is, or your API changes, your standards are changing. Let's say in 5 years we find out ourselves that MQTT no longer a thing, and we have another stable, cool protocol. If you have API gateway on top of it, you can ensure that both devices will be connected to the different protocols, because API gateway obviously will be interested in keeping all the major protocols supported. But at the same time, backend can support anything, right? So by involving this abstraction, you can ensure that you can be man in the middle and patch things dynamically. Right. Now about the standards. So it's not something we currently can solve, obviously, but it's related to the previous point. If some of the standards are changing, and they will change, definitely, because it's really unstable technology right now, tools like API gateways will pick up that first. So you don't have to do it. Right, so, okay. And when we're talking about businesses, right now, since we don't have that much tools, or they created for the really big players, and there are not very much companies which start IoT businesses in terms of devices, actual devices. So there are a lot of companies which start businesses which manage our devices, but not that many who actually create devices. And especially when it comes to the businesses, they're interested in some stable solutions which can be supported over the years, and they can build business on top of it. And if you rely on some on some unreliable code, and you have to maintain it by yourself, and everything constantly breaks, and etc., it's obviously not the solution for the big business. And in this case, if API gateways, not only the TAIC, but the rest of gateways move to this business, it creates more opportunities and more trust in this industry. And in terms of this topic, if the main idea is that we need to have success stories, right? So we need to have a lot more IoT devices which are safe, which respect privacy and all this kind of stuff. But it's not going to happen until we have the right tooling to implement it on the scale. Right. So, and now when we're talking about privacy, as mentioned, the most of the tools right now we have is kind of static. So you have a list of configuration files, user passwords, some ACL rules in your configs, but that's all. You start the server, you can have the static rules, but what if a person in one country wants to disable some option, or let's say you can dynamically detect that this device is from United States and enable some features. And for another device who is from France or from Spain, actually disable those features, or for example, strip some data from it to make it work with local regulations. And this kind of stuff you can do with gateway as well. And so regarding regulatory standards, they changed a lot. And when they change, they can cost a lot of business to the money, because we've seen right now a lot of GDPR and all these laws. When they implemented, a lot of businesses started to lose money. They have to implement some hacks to avoid it, and etc. And you can't avoid these changes. It will happen anyway. But what you can do is you can try to rely on the tools which will help you to migrate to the new standards. Right. And in general, I think that's all. So if you're talking about availability, so it's currently in active development, happens on our GitHub. Goal is to ship it in our next major release with at least initial version. It will be available as open source, and private beta starts now. So we need your help, everyone who involved in IoT. If you're interested in testing actually the stuff, we need some knowledge of the industry to actually do it the right way, and not just do it. So your contributions are welcome, and please send your feedback to us. We'll read everything and answer to everyone. So yeah, I think that's all.
Thank you, Leonid. Are there any questions?
Thank you. My name is Alexander Salas. I'm Spanish spoken. I am the lead developer of MDM, Mobile Device Management. We are using MQTT, but we have a better performance and stability with the MQTT, but unsecure port. When we added a security element and security TLS, and we encrypted the communication, we have many issues we want to remove. MQTT. We are using Eclipse Pajo, the library for Android. If you know another solution, another broker, because Facebook works, but they don't share.
Yeah, yeah, definitely. So if you're talking about actual performance performance slide which I showed you, it's actually assume that authentication happened behind this performance test and all the analytics logs for it. So in this case, it was JWT authentication, but it also can be mutual TLS authentication or whatever it is. But general idea is that Type API gateway is very performant, and its main goal to be like this, right? So that's one of the issues which when you wake up in the morning, you unlikely will think that, hey, I want to make this authentication faster, but actually people from our team do it. Right? So it's our job. So I think solutions like this, if you implement it and if you want to test it, actually can replace what you are doing right now.
The GPSR or MQTT over HTTP, it is your gateway, your solution.
Right. So what we're talking here is when you have input of MQTT or MQTT over protected with TLS, and output also MQTT. But in general, in MQTT world, there is support for WebSockets over MQTT over WebSockets when they use as a transport, but non-meta information isn't involved. So we're going to most likely support this as well. It's quite easy to implement. But it's between MQTT client and MQTT broker.
Yes, we try to, because Android does not support service as background, so we need to remove also QTT for other versions of Android. But we are using Firebase FCM, and we will use HTTP to synchronize the task for the MDM. So this is will be nice a solution if we don't use push services, and we are using this gateway and for pros like that we saw Google services.
Right. Yeah. Yeah, that does make sense. In general, I don't see that much people who are happy with MQTT, but general idea is that there are no alternative here. So, for example, is alternative to MQTT right now is often HTTP2 is proposed as alternative because it allows asynchronous multiple requests happening at the same time on the same connection, and in general, it's more performant. But it's also have way more overhead than MQTT, and doesn't have features like quality of service, last will, and etc., which are essential for IoT. And you have to build some hacks on top of it to somehow emulate this behavior. So right now, I don't see that much alternative to MQTT if you want all those kind of features. But it's definitely possible to come up with, if you will choose something, most likely I would recommend HTTP2.
Okay. Any more questions? And what about Kafka, for example?
Right. So Kafka in general is a broker, right? So it's a message broker, and you can easily turn it into MQTT broker if you put some additional layer on top of it. So Kafka is quite dumb in the sense because it just sends this message and it broadcasts to another client, but it doesn't understand things like last will and quality of service is supported. So Kafka is very close to MQTT solution, and you can use it with some additional layer on top of it. But as mentioned, there are a lot of even open source like HiveMQ solutions, which build specifically for MQTT protocol, and they are quite production ready, I think.
Yeah, so my question is, you've been showing in the slides how you were able to match some of the things from the MQTT protocol with HTTP, like status code and the body. Yeah. I guess that was the easy part. So my question is, was there anything in the two protocols that were so distant that you were like, we don't know how we're gonna do this because they do different things?
Well, yes, there are some parts here which I have to emulate. So for example, when you do a subscribe request, you can subscribe not to a single topic, but to multiple topics. And what in terms of what I actually described, it should be described as two separate requests, but actually it's one request from MQTT side, which should be translated to two HTTP requests. But in case right now it's not implemented, but I'm aware about this issue, and it will be like this. So we split this MQTT request on two requests. Yeah, send it to the server, get acknowledgements from the response, merge it, and respond to the client. So it can be done. Yeah. But otherwise, MQTT protocol is quite simple from spec point of view. I implemented various protocols. MQTT probably is the simplest one.
Okay, thank you. We don't have time for more questions now, but you can talk to Leonid during the networking
I will be
part.
available after this. So if you want to talk with me, chat about anything, feel free to talk. Yeah.
Thank you.